morning, good afternoon, and good evening. This presentation is brought to you by ConstructionSmart.net. The purpose of this presentation is pretty much to provide folks within the civil engineering industry an overview with respect to atmospheric infrastructure, what the project entails, and how they could actually position themselves to utilize the resources we have to offer. In a nutshell, the atmospheric infrastructure is pretty much a program that will have civil engineers utilize ozone generators and atmospheric gases to monitor the development of the atmosphere for planets such as Mars, and the scale of the size of the project would be within that of our hydroelectric plants. We do intend to offer a variety of management process and flows that many folks within the civil engineering arena are actually familiar with, supported with a variety of pricing and structural solutions to allow them to actually succeed in this arena. On our site, which is our constructionsmart.net, we actually provide details concerning how we came to the determination that it's possible to actually manage an atmosphere. We do that by recognizing comparisons between atmospheric elements. Given that this particular project focuses more so on Mars, we compared the atmospheric element compositions between the two planets that allowed us to determine the type of chemical compositions that would be needed to maintain an atmosphere in Mars. We also took into consideration a huge factor, which is the atmospheric footprint, and we pretty much show our civil engineers the size at which the atmospheric gases need to cover over a given period of time. We then move forward to the third step, where we also, allowed civil engineers to have that state of mind that it's possible to manage an atmosphere due to the fact that here in the U.S. highways are infrastructures which are actually managed by civil engineers. And the key thing to take into consideration is that the estimated atmospheric infrastructure needed to maintain an atmosphere in life is between a ballpark of about 777,000. That is way less than the amount of um, highways that are actually being managed in the US. There are over 3.9 miles worth of road that are actually actively managed with civil engineers. And key thing to take into consideration is that we do not want to make the atmospheric infrastructure a huge burden in terms of the amount of hours that the civil engineers have to uh, 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 dedicate to actually manage the resources. We'll be using a variety of robotic applications to allow them to achieve those goals. The fourth step, which is evaluating distribution capacity, is something that we touched base very briefly on a sheet that allows us to evaluate how we know we can actually manage an atmospheric infrastructure in a planet such as Mars, and that begins on the next segment of this presentation. The atmospheric scoreboard is pretty much a worksheet that we actually use to show that we are able to determine how fast we can utilize ozone generators to actually maintain an atmospheric infrastructure and have the project pretty much up and running within a 10-year cycle. The key valuations that were taken into place is pretty much the atmospheric landscape of Mars in terms of the different layers of the atmosphere in comparison to that of Earth, and those variables actually addressed within this segment of the evaluation worksheet. The first key thing that folks have to take into consideration is the distance, and we determined that by C26. C26, here we go. By recognizing the size of the ozone layer that's needed, and this is based on a latitude's perspective. It comes to a ballpark of about 20,817 miles worth of atmospheric infrastructure that needs to be consumed with atmospheric gases by a given square meter or square mile, and we'll get into further details concerning what the specific figures actually are. A huge thing to take into consideration is estimating the ozone density. Key thing about atmospheric infrastructure, since ozone has a higher density than carbon dioxide, given that a huge portion of the atmospheric elements in Mars are carbon dioxide. Carbon dioxide is fairly lighter than the ozone density, thus making the carbon dioxide rise higher to the stratospheres of Mars relative to ozone, because ozone is much more heavier. So a huge thing about the atmospheric infrastructure is pumping out a given amount of ozone at a given rate to have the environment pretty much occupied with ozone. The second key thing is that what we did is we converted F8, the estimated uh, latitude miles, we divided that by 3. That's due to the fact in the ozone industry they use meters more than feet. In the construction and civil engineering industry in the US they use feet. And we did that to allow us to determine the amount of ozone that needs to be put out in kilograms per square feet per hour to maintain an atmospheric infrastructure. So the amount of ozone required in miles and kgs comes to a ballpark of about 78 million per hour. So another key thing is that in the ozone industry they use milligrams in terms of the amount of output that ozone generators put out at a given period of time. We have a worksheet, and this is pretty much industrial standard. For square feet of a ballpark of about 4,000 square feet for 1 hour duration, an ozone generator puts out 3,500 worth of atmospheric or pretty much ozone, and the price at which that ozone generator goes at is at 600. The amount of hours in a year to maintain ozone comes in at 3,540. I will clarify what that actually means within the estimation process of atmospheric infrastructure. So once you've converted that actual figure from the kilograms to the milligrams, so we need to put out over 78 trillion milligrams worth of ozone per hour to maintain an atmospheric infrastructure in Mars. The quantity of ozone output at the standard 3,500 milligrams. What this is pretty much telling us is that if we utilize the current output of ozone generators in the industry, we'll have to wait over 22 billion years for us to actually maintain an ozone if we use ozone generators that are actually able to put out 3,500 worth of um, ozone per hour. So that means you have to wait 22 billion years. So what happens if you actually increase the amount of output of an ozone generator and you give yourself a ballpark period of about 10 years to actually build an ozone? Key thing on that, the key thing that we actually utilized to come to that determination is that we took the 22 billion, which was E20, 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 E20. Okay, okay. Divided by the amount of hours in 1 year. Uh, okay, to correct myself, it actually takes 2.6 years, 2.6 million years at 3,500 milligrams to actually maintain an atmospheric infrastructure to the point whereas the density of ozone is actually able to push up the carbon dioxide in Mars. So for us to determine the amount of output ozone generators need to be putting out per hour to maintain an atmospheric infrastructure in 10 years, we nudged on the 2.5 million years and we divided that by 10. So now this actually represents the multiplier at which the ozone generators need to increase the output. So you take the standard industrial output of an ozone generator, which is 3,500, and you multiply that by the multiplier that needs to increase the output of an ozone generator, and that gives you the amount of ozone that an ozone generator needs to be putting out per hour to maintain an atmospheric infrastructure over a 10-year period. It comes in at 917 million. So over 24-hour period, how much ozone needs to be put out by an ozone generator? Well, it comes in at a ballpark of about 22 billion milligrams worth of ozone needs to be put out per hour to maintain an atmospheric infrastructure over a 10-year period. Second step, how much of ozone does an ozone generator need to put out per year to actually maintain an atmospheric infrastructure? Well, it needs to put out over 7 trillion worth of ozone per year to maintain an atmospheric infrastructure over a 10-year period to actually manage and maintain an atmosphere in Mars. A key calculator that we also did is that we took the same multiplier, the 200 62,000 multiple and multiplied it by the standard price of an ozone generator, which actually gave us a cost on roughly how much an ozone generator would actually cost. And an ozone generator that's going to put out over 700 trillion worth of ozone per year should cost a ballpark of about 157 million US dollars. Case in point, uh, we have the capacity, and the hydroelectric utilization around the world proves that if you use the management flows of infrastructure, you can actually manage atmospheric infrastructure. The hydroelectric global usage comes in at a total output of over 21 trillion. Based on our evaluations, we need to be putting out over 7 trillion. So if we've proven for over 50 years that we can manage hydroelectric plants which actually put out thermal energy, which has the same amount of footprint as ozone generated to some extent, then we are more than capable of managing an atmospheric infrastructure. The difference in terms of output, in terms of the amount of resources, in terms of infrastructure that we have, we are over 2,785 times capable of actually managing an atmospheric infrastructure of Mars at the get-go based on what we've actually evaluated. And that pretty much concludes the evaluation of our determination of maintaining an atmospheric infrastructure utilizing ozone generators and atmospheric gases. A huge factor that determines the success of this engagement is the supplier's output, and that's something that we're not aware of at this point in time. But moving on, navigating our site, when you go to the atmospheric infrastructure, we pretty much provide an overview for civil engineers to actually assume the scale of the project, to position themselves, and the type of resources that they'll actually be utilizing. So the shuttle will be distributing the robots that will be operating the ozone generators, and we'll be using a variety of atmospheric gases to accomplish that. The civil engineers will be operating these equipments utilizing our remote satellite communication systems. Cost mitigation solutions, because we're not anticipating any sponsors at the inception of the program, is that we're working with the suppliers to have the expenditures lower lower than 1 million, and we're also positioning ourselves to work with a ballpark of over 400 civil engineers per state, which puts us at a ballpark of about 13,000 civil engineers from the US. And working with such a consortium of civil engineers will allow us to reduce the costs and have a variety of eyeballs pretty much overseeing the project. There are also a variety of research tax credits that would be made available to the researchers to reduce the uh, tax implications of their business on a broader scale, but we recommend that you consult with the CPA to see how you can absorb the cost. In addition to that, we'll also be taking a step further to try and market the commitments of civil engineers to get the corporate entities to participate within this particular engagement. The next step civil engineers need to do is on our site, just subscribe for services. Our research and our work qualifies as RD tax credit, as you can actually recognize that we're actually positioning many American businesses to actively participate within the aerospace arena, and we encourage civil engineers to subscribe for services. We'll be promoting the service and expertise of civil engineers that engage in the program to be solution service providers for interplanetary infrastructure development projects with corporate clients that will be participating within the aerospace arena. Beyond the scope of providing atmospheric infrastructure services, we'll also be participating a whole lot in aerospace development projects from spaceport, spaceships, space vessels, spacecraft, contracting opportunities that would allow civil engineers to work hand in hand with guys within the aerospace to provide finish out development products or solutions for spacecraft or space development or construction or related projects and other infrastructural development projects associated with interplanetary activities. So if you're a civil engineer, we encourage you to subscribe. The service does come at a higher sticker price, but you must understand you can deduct this at the same time. We shall be recommending your services to other business establishments. So go ahead, subscribe, and check us out once again at constructionsmart.net. We look forward to promoting your business. Join our team. Thank you.